All right, we're going to leave factoring for just a little bit, and we're going to talk about in 15.4, I can simplify expression using rules for exponents. So we're going to go back and talk about exponents for a little bit. All right, now the warm-up question has a couple things. It says two parts of an exponential expression are called so we've got a base in an exponential expression, and we've got the exponent. So remember, the base is the number that we use down here, and then the exponent is the number that we write a little bit smaller, and then we call that superscript. So we've got some examples down here. And then it says complete each statement below, then simplify the examples. So what we've got is we've got the product rule for exponents. So again, this is all review. You've seen stuff like this before. When we multiply expressions with the same base, we add the exponents. We add the exponents. So on a problem like this where we've got 2 to the third times 2 to the 7th, the base is still going to be 2, but we add the exponents. So that's going to be 2 to the 10th. And this is a pretty large number. We won't worry about throwing that in the calculator. If we do get something like 2 to the third or 2 to the 5th or something like that, 2 to the 5th is 32. We'll go ahead and write those numbers. But if we get big numbers like this, we'll just go ahead and leave it in that exponential form. Quotient rule for exponents: when we divide expressions with the same base, then we subtract the exponents. We subtract the exponents here. Now, I like to think of it this way. I always like to think I'm going to subtract the small exponent from the big exponent, and then I'm going to leave them where there were more of them. So on this one, what I'm going to do is I'm going to say, look, there are 3 of them on the top, and there are 7 of them on the bottom. So these 3 will cancel 3 of those. So that's going to leave 2 to the 4th on the bottom. So we've got 1 over 2 to the 4th. We'll talk about a different way to think about that in just a second when we talk about negative exponents. And then we've got the power rule for exponents. When we raise a power to another power, then we multiply. So let's write multiply the exponents. So on this one, we've got 2 to the third raised to the 7th. And notice that I'm using the same base in all of these examples here, and then the same exponents. We're just applying them differently. So product here, quotient here, and then a power raised to a power. So this is going to be 2 to the 21st. That is a gigantic number. We certainly don't want to write down what that one is. And now here's where we're going to review negative exponents. Remember, a negative in the exponent means reciprocal. So what we're going to do here is this has a negative exponent right here. And what a negative exponent means is if that exponential factor is written in the top, we can write it in the bottom. If it's written in the bottom, we can write it in the top. And what it does is it changes the sign of the exponent. So this negative here means reciprocal. So what we're going to do is we're going to put that on the bottom. It's going to change the sign of that, so that's going to be 2 to the third on the bottom. And then what's left on the top is a 1. Now we'll deal with situations where there's not a 1 left because there's other factors and things like that. But this is a good example right here. And then we're going to come back up here and we're going to take a look at this one. So on this problem right here, and I'm going to change colors so we can see that that's done differently. What I did is I subtracted the top one from the bottom one because the bottom one was bigger and I had 2 to the 4th on the bottom. You could also do this. So you could do 2 to the third minus the 1 on the bottom. So that's going to be 2 to the negative 4, because 3 minus 7 is negative 4. And then a negative in the exponent means reciprocal. So again, we're going to change that sign by moving it into the denominator. So again, you'll notice that we get the same answer either way. So we're in good shape there. And then the last property we want to talk about today is any number raised to the 0 power is 1. So we're going to take 2 to the 0 power. Now, a lot of people think that would be 0. It's not. You can go ahead and check on your calculator. And if you want to go back and take a look in earlier this year, or maybe in 8th grade or something like that, previous class, you maybe went through a rationale for that. So what we've got here is, this is, 2 to the 0 is 1. So there's our answer on that one. And I want to run through one more quick thing. I want to talk about the order in which we do things and one way that you can keep these straight. So we learn how to add, then we learn how to subtract, then we learn how to multiply, then we learn how to divide, and then we learn about exponents or powers, okay? So I'm going to change that to power so it matches up with the vocabulary that we're using. Well, what I want you to notice is if we're doing multiplication with exponential expressions, we actually kind of take 2 steps backwards on this list and we actually add the exponents. If we're dividing, watch what happens if we take 2 steps backwards. We end up with subtracting. And if we're doing powers or exponents, if you take 2 steps backwards, we end up multiplying. So it's kind of like when we're dealing with exponents, we're kind of stepping back 2 steps in difficulty of the operation. Now, that's one way to remember it. If you've got a different way to remember it, that's awesome. So now, when we talk about simplifying expressions, that is one of the most valuable skills that you can have in math. We simplify things all the time. And the simplified answers to these warm-up questions, so all of these right here, because they had numbers in them, you can actually verify those using a calculator. So if you want to check those using a calculator, you're welcome to. You could type this into your calculator, do the multiplication, and then type in 2 to the 10th. It'll tell you the right answer. Same thing with 2 to the negative 3. It'll give you the same answer as 1 over 2 to the 3rd. All right, now, not everything can be verified this way because sometimes expressions contain variables, and that's not something we can generally type into a calculator. But the nice thing about the rules for exponents is they work regardless of whether or not we're working with numbers or if we're working with variables. And that's what we're going to see a lot of today. We're going to be simplifying with some variables in them in exponents. So paying attention to the details and knowing the vocabulary and the properties, that's really going to be helpful when we start simplifying these. So let's go ahead and take a look at this. On this problem right here, we've got a multiplication problem. We've got this factor times this factor times this factor. And the first thing we notice is we've got this ugly negative 19 to the 0. Well, remember, any number to the 0 power, this is just 1. So this would be times 1. So it's really not going to influence what goes on here. We're going to take advantage of the commutative property of multiplication, and I'm just going to multiply the 4 and the 3 together. That's going to be a 12. And then what we've got here is we've got a x to the 5th times x to the 2nd. Now, I'm showing quite a bit of work here. I could have even written this 12 as a 4 times 3. But let's go ahead and take care of this. We've got a coefficient of 12, and then we're multiplying these expressions. They have the same base, so we add the exponents. So this is going to be x to the 7th. So I'll go ahead and circle that, and we're done. A lot of these go very quickly. This one is a quotient. This is a division problem. So let's go ahead and simplify the fraction with the numbers just like we normally would. So I'm just going to go ahead and simplify this by reducing this. 3 goes in here once, 3 goes in here 5 times. So you'll notice that we have a 5 in the denominator. Then we've got x to the 4th on the top and x to the 10th on the bottom. We could go through and do x to the 4th minus 10, subtract the bottom one from the top one. Then we get x to the negative 6 on the top. But then we don't like writing things with negative exponents. We want to write them with positive exponents, as it says in the instructions here. So we'd have to move that into the denominator. I find it a whole lot easier to think about it this way. We've got 4 x's on the top. We've got 10 of them on the bottom. These 4 are going to cancel with 4 of those, so there'd be 6 of them left there. So this is going to be 5x to the 6th. Now, there's nothing left on the top, but keep in mind, when everything cancels through multiplication or division, there's always a 1 left, and we do have to write it when it's in the numerator. So there's our answer there. And let's take a look at this ugly mess. First thing I might try and do on this one is let's go ahead and simplify the numbers. We can take care of that pretty easily. This is just going to be a negative 4. That's left on the top. And then what I'm going to do is I'm going to write down, let's write down the x to the 5th, and I'm going to move the x squared to the numerator because it's negative down here. If I move it up to the top, it changes the sign of the exponent. The y's I can take care of because there's really one y right there. That's going to cancel with one of those, and that's going to leave 2 there, so that's going to be y squared. And then we've got a z here, and then we've got a z to the negative 6. Well, we don't like negative exponents, so we can change the sign of that exponent by moving it up in the numerator. So that's going to be z to the 6th. Now, there's nothing in the denominator, so I don't have to write this, but I'm going to go ahead and put a 1 there. And then I realize that when we're done with this, we're not going to write that at all, because what we have here is for a coefficient, we have negative 4. Then we have x to the 5th times x to the 2nd. We add those together because they've got the same base, so that's going to be x to the 7th. The y's, there aren't any other y's, so this is just going to be y squared. And then we have 1 z here and 6 more z's there, so we would add those together. So we're going to get z to the 7th. So we're going to go ahead and circle that. That would be our answer there. And then we'll slide down and let's take a look at these next few problems here. So on C, we've got this parentheses with this ugly mess in the side, and then it's raised to the power there, and then we've got the 5 on the outside of the parentheses. So in the note, it says the exponent applies to every factor in the parentheses. So why doesn't the exponent apply to the 5? So let's take a look at this, and let me show you how to do this, and then we'll answer that question. So we're going to apply the power property of exponents. So I'm going to put the 5 out here, and then what we have here is we've got negative 2 raised to the 2nd. Now remember, that is a negative 2 raised to the 2nd. So there's going to be 2 negatives here. Then we've got x to the 3rd raised to the 2nd. Then we've got y to the negative 6 raised to the 2nd. Now I'm showing tons of work here. I will do a couple with a shortcut on the next few. So here's what we get. We get 5 and then negative 2 squared, so that's going to be a positive 4. Then we have x cubed raised to the 2nd. Remember, power to a power, we're going to multiply those, so that's going to be x to the 6th. And then we've got a power raised to a power here, so that's going to be y to the negative 12. So let's take a look. We can simplify this number right here, so that's going to be a 20. x to the 6th is totally fine, but we don't want to write a negative exponent on this one, so we're going to move that in the denominator, and we're going to end up with a y to the 12th in the denominator. So this is probably the best way to write this one. Now, let's come back and answer the question. Why doesn't the exponent, why doesn't that 2 apply to the 5? Well, it's not in the parentheses. When it's not in the parentheses, that exponent doesn't apply to it. It only applies to everything in parentheses. Now, if you're pretty good at these, you could probably go through and say, hey, I'm going to square negative 2, I get 4. 4 times 5 is 20. We've got that right there. Then we've got x to the 3rd raised to the 2nd. We're going to multiply those exponents. The 3 times the 2 is a 6. And then we've got the y to the negative 6 times 2, or sorry, raised to the 2nd. We're going to multiply those exponents, so that's going to be a negative 12, and we recognize that we can't have a negative 12 for an exponent, so we move that in the denominator. Okay, lots of good problems here and lots of skills to work with. Now, on these last two, it's going to be really good to try and simplify what's inside the parentheses before we apply the exponent on the outside. We could have done that here. I'm going to take a look at both of these. These are a little bit more messy maybe. So let's go ahead and simplify this. This is going to be, let's see, I can certainly get rid of that. And because there's a different exponent applied to each one of these, let's write down what we've got here. This is going to be 3 raised to the 3rd. That's going to be 27. This is going to be a to the 4th raised to the 3rd. So that's going to be a to the 12th. This is going to be b to the 3rd raised to the 3rd, so that's going to be b to the 9th. Now we've gotten rid of this b right here because it was just b to the 0, that's a 1. So let's apply the 2 as an exponent to the negative 6 and the a, so negative 6 raised to the 2nd. Now don't forget that negative is in the parentheses, so that exponent applies to that. That means there's 2 negatives and 2 6s, so that's going to be a 36. And then we have a squared. Remember, this is a to the 1st, power to a power. We're going to multiply those. Now we want to go ahead and simplify here. I can go ahead and reduce this fraction. 9 goes in here 3 times. 9 goes in there 4 times. So I'm going to have 3 on the top and 4 on the bottom. I can go ahead and write my fraction bar here because I know I'm going to have something in the denominator. And then we've got 2 a's on the bottom and 12 of them on the top. These 2 cancel with 2 of those. That means there's 10 left. And there were most of them on the top, so that's where they end up. And then again, we've already got the b simplified there. So we get 3 a to the 10th, b to the 9th over 4. Now this is where it's going to be really important to simplify what's inside the parentheses before we apply this exponent on the outside. Let's clean this up just a little bit. The first thing I notice on this one is we've got some numbers here. We've got a 2 and a 6 and an 18. This is a multiplication problem on the top, and we're dividing by 18, so we can just do some cross-canceling here. So I'm going to cross-cancel the 6 with the 18. That's going to be a 3. There's no other numbers we can cross-cancel, so I'm just going to write a 2 on the top and a 3 on the bottom. Let's take a look at this q right here. I've got a q to the negative 4. Let's go ahead and write that on the bottom. So this is going to be q to the 4th down here. So here's what I've got. I've got q to the 5th on the top, and I've got q to the 7th on the bottom. So we'll take a look here. Let's go ahead and finish simplifying this, because really this is still being raised to the 4th. So I'm going to end up with 2/3, and then we've got, let's see, there's 5 q's on the top and 7 q's on the bottom. These 5 are going to cancel with 5 of those, so that's going to leave q to the 2nd. Now, one thing that happens a lot is people get carried away and they just simplify this and then they'll circle that answer. Again, don't forget that we've got that 4 on the outside for an exponent, so we're going to do 2 to the 4th. And then we're going to do 3 to the 4th, and then we're going to do q to the 2nd raised to the 4th. That exponent gets applied to each one of those. So these are small enough numbers. Let's go ahead and figure out what they are. This is 2 to the 4th. That's 16. This is 3 to the 4th. That would be 3 squared times 3 squared. 3 squared is 9. 9 times 9 would be 81. So 3 to the 4th is 81. And then q to the 2nd to the 4th, again, power raised to a power. We multiply those, so we get q to the 8th. So we'll go ahead and circle that, and we've got that answer. Now, we're done simplifying those, but I want to throw out a thought question for you to take a look at. So this is a true equation. 4 squared times 5 squared equals 20 squared. Now, you can double check that on a calculator if you would like to. So the question here is, why do we multiply the bases and then keep the exponents the same? So we've got a 2 as an exponent all the way through, but then we just multiply the 2 bases together to get the 20. Well, one reason would be we're applying the properties of exponents and then taking advantage of the commutative property of multiplication. So remember, the commutative property allows us to move stuff around. So here's what I've got. I've got 4 times 4 on this one, 5 times 5 on this one, and we're going to rearrange that. So I'm going to do 4 times 5 times 4 times 5. So this is going to be 20 times 20. And that's what 20 squared means. Remember, an exponent is a short way to write a long repeated multiplication problem with the same base or same factor. So that's one reason. And then the other reason, and I'm going to change colors for this, the other reason is that we're kind of using the power property in reverse order. So let me show you what I mean by that. This exponent of 2 has kind of been applied to both of these. Well, one thing that we could think of is we could say, well, look, what if we just do 4 times 5 and then we apply the 2 on the outside? So if we applied this, this would be the same thing as having 4 squared times 5 squared. So then what we end up with is if we put those together, do that multiplication, we end up with 20 squared. So it does work both ways. So go ahead and do the self-assessment as to how well you understand this stuff right now, and then good luck on the assignment.